Hello everyone, myself Mrs. Sarika Narde Patil, Assistant Professor from Dr. Shivajirao Kadam College of Pharmacy, Kasbedigra, Sangli. In this video, I am going to discuss about isomerism and its types. What is meant by isomerism and what is meant by isomer? Isomer word derived from the Greek word isos plus meros. Isos means same or equal and meros means part. It means equal part. Then which part is equal? That is molecular formula is equal. Then which part is different? That is its physical and chemical property is different. Then why there is difference in the physical and chemical property? This is because of the difference in the arrangement of atom within a molecule. Then what is meant by isomer? Isomers are the compounds having similar molecular formula but they have different physical and chemical properties due to difference in the arrangement of atom within a molecule. And the phenomenon is called as isomerism. Now we will discuss about the types of isomerism. It is of two types. First is structural isomerism and second is stereoisomerism. Then what is the difference between these two? In case of structural isomerism, it is the isomerism which is caused due to difference in the arrangement of atoms within a molecule without any reference to space. While in case of stereoisomerism, that is the isomerism which is caused due to difference in the arrangement of atom within a molecule with reference to space. That is, in case of structural isomers, these compounds have same molecular formula but they have a different structural formula. While in case of stereoisomers, these are the compounds having same molecular formula, even same structural formula, but they have a different arrangement of atoms with respect to space. It means they have a different spatial arrangement, means they have a different configuration. We will discuss upon the types of each structural as well as stereoisomers in detail. There are total 6 types of structural isomerism. First is of chain isomerism, second is positional, third functional isomerism, fourth one is the ring chain isomerism, fifth one is the metamerism, and sixth one is the tautomerism. First type of structural isomerism is chain isomerism. This is the phenomenon in which compounds having same molecular formula but they differ in that there is a difference in the sequence in which carbon atoms are linked to each other. And such phenomenon is called chain isomerism and such compounds are called as chain isomers. For example, one compound will exist in a straight chain form while another compound will be in branched chain form. Here we can see the example of butane which is a straight chain compound. While in case of 2-methylpropane, it is a branch chain compound. Butane as well as 2-methylpropane, both the compounds have same molecular formula, that is C4H10. However, the sequence of carbon atom linking to each other is different and such isomers are called as chain isomers. Second type of structural isomerism is positional isomerism, in which the compounds have same molecular formula but they differ in the position of functional group present in a molecule. For example, but1-in and but2-in. In case of but1-in, the double bond is present at first position, while in case of but2-in, double bond is present at second position. Means the compounds having same molecular formula but difference in the position of functional group is called as positional isomer. Third type of structural isomerism is functional isomerism. Means the phenomenon in which compounds have same molecular formula but it has a different functional formula or different functional groups present in a molecule. For example, propanoic acid and methyl ethanoate. These two compounds have same molecular formula, that is C3H6O2. However, they differ in the presence of functional group. That is, in case of propanoic acid, the functional group is carboxylic acid. While in case of methyl ethanoate, the functional group present is ester moiety. Both have same molecular formula, that is C3H6O2, but the presence of functional group in both the compound is different and such compounds are called as functional isomers and such a phenomenon is called as functional isomerism. The fourth type of structural isomerism is called metamerism. These compounds are also having same molecular formula, but they differ in that there is an unequal distribution of carbon atoms on either side of functional group. For example, when we consider the example of diethyl ether and methyl propyl ether, the functional group present is same, that is ether moiety. But in case of diethyl ether, on either side of ether oxygen, there are same number of carbon atoms. That is 2 carbon atoms on right hand side as well as 2 carbon atom on left hand side of the ether oxygen. However, in case of methyl propyl ether, on left hand side of ether oxygen, there is only 1 carbon atom. On right hand side of ether oxygen, there are total 3 carbon atoms. Means, in case of methyl propyl ether, there is unequal distribution of carbon atom on either side of the functional group. And the isomers, which are having same molecular formula, but they differ in the number of carbon atom on either side of functional group, are called as metamers, and such a phenomenon is called as metamerism. Fifth type of structural isomerism is a ring chain isomerism. Means the phenomenon in which compounds have same molecular formula but they differ in the mode of linkage of carbon atom. Means these are the isomers having either open chain structure or closed chain structure. For example, here propene and cyclopropane, these are ring chain isomers of each other. In case of propane, this structure is open chain structure, while in case of cyclopropane, this is a closed ring. And thus, the isomers having same molecular formula, but if there is a difference in the mode of linkage of carbon atom, such isomers are called as ring chain isomers. And such a phenomenon is called as ring chain isomerism. The sixth type of structural isomerism is called as tautomerism. It is the phenomenon in which compounds have same molecular formula, but there is a difference in the functional group. And such isomers can be spontaneously interconverted into one another and they exist in dynamic equilibrium with each other. For example, keto-enol tautomerism, a very well-known example is ethyl acetoacetate. It exists in two forms. First is the keto form, another one is the enol form. Another example of tautomer is a nitroethane and isonitroethane, which is a acid and nitro form. In case of first structure, here nitroethane, which exists in a nitro form. We can see here free nitro group and O2 group here. While in case of isonitroethane, it exists in acid form. This is because the acidic proton is present on the nitro oxygen. And thus, there is a difference also in the position of double bond. In case of nitro form, the double bond is present between nitrogen and oxygen. While in case of acid form, proton is added to the oxygen and therefore the double bond gets shifted between NO to N and C. And thus, the nitro form and acid form, these two compounds have same molecular formula. However, it has a different functional group. And these two compounds can exist in dynamic equilibrium with each other and they can be spontaneously interconverted into one another. And such a compounds are called tautomers and such a phenomenon is called as tautomerism. Then the second type of isomerism is called as stereoisomerism. Means the phenomenon in which compounds have same molecular formula, even they have a same structural formula, but they differ in the spatial arrangement of atoms within a molecule. Means these compounds have a different configuration. Means their arrangement of atom within a molecule with reference to space is different. Again, these stereoisomers are classified into two types. First is geometrical isomer and the phenomenon is called geometrical isomerism, and second is the optical isomerism. The first type of stereoisomerism is a geometrical isomerism. Means these are the compounds having same molecular formula, same structural formula, but they have a different spatial arrangement. And these compounds have such an arrangement of atoms or groups that around the carbon-carbon double bond, there is a difference in the arrangement. That is, suppose two similar groups are present on the same side of double bond. In case of cis-2-butene, we can see two methyl groups which are similar groups. Even two hydrogen atoms, they are also similar. These two similar atoms or groups are present on the same side of double bond. Such a compounds are called as cis-isomers. And in the compound where two similar groups are present on the opposite side of the double bond, here we can see two methyl groups are present on the opposite side of this double bond, means such a compounds are called as transisomer. That is the phenomenon in which compounds having same molecular formula, same structural formula, but they differ in the spatial arrangement of atoms or groups around carbon-carbon double bond are called as a geometrical isomers, and the phenomenon is called as geometrical isomerism. In case of these cis and trans isomers, these compounds differ in the spatial arrangement of atoms, and therefore these compounds exhibit different physical as well as chemical properties. Due to difference in their properties, it is very simple to isolate these isomers from one another. One more additional point is that geometrical isomerism mainly arises due to restriction in rotation about carbon-carbon double bond. This is because whenever we rotate carbon-carbon single bond, it is very simple to rotate the carbon-carbon single bond. This is because there is a sigma bond. It can be easily rotated. However, in case of double bond, there is existence of pi bond also, and pi bond restricts the rotation around carbon-carbon double bond. And therefore, the restriction in rotation about carbon-carbon double bond is mainly attributable for formation of geometrical isomers. When we compare the stability of cis isomer to that of the trans isomer, it was found that trans isomers are more stable as compared to the cis isomer. This is because in case of trans isomers, two similar groups are present at a maximum distance apart, means they are present on opposite side of the double bond, and therefore there will be less steric effect, less steric strain in the molecule, and thus it will have a greater stability. However, in case of cis isomers, two similar groups or bulkier groups are present close to each other, and therefore there will be more steric strain in the molecule, and thus cis isomers are less stable as compared to the trans isomer. One more point, that is cis isomers can be interconverted into trans, or trans isomers can be interconverted into cis only by applying heat or by UV radiations. Then the next point regarding or the last part of the stereoisomerism is optical isomerism. This is also one of the type of stereoisomerism. It is a phenomenon in which compounds have same molecular formula, same structural formula, but there is a difference in the arrangement of atom with respect to space, means they have a different spatial configuration. And because of the molecular asymmetry, these molecules has ability to rotate the plane of plane polarized light. The molecules which will rotate plane polarized light towards right hand side directions are called as a dextrorotatory compound, and the molecules which has the ability to rotate the plane polarized light towards left hand side direction are called as levorotatory form. While an equimolar mixture of both dextro as well as levorotatory compound is called as a racemic mixture. And remember one thing, racemic mixtures are optically inactive. This is because in racemic mixture, we take equimolar mixture of both dextro as well as levorotatory compound, and therefore optical rotatory power of dextrorotatory compound is superimposed or overcome or opposed by optical rotatory power of levorotatory compound, and therefore these optically rotatory powers get cancelled out, and thus racemic mixture is optically inactive. In case of optical isomers, if these isomers are non-superimposable to their mirror image, for example, D-alanine, L-alanine, when we see its structure, these are the mirror images of each other. But these mirror images are non-superimposable onto each other, and such isomers are called as enantiomers. While another concept that comes under optical isomerism is about distereomerism, in which these are also optical isomers, but they are not mirror images at all. Enantiomers, diastereomers, both these are the types of optical isomers. Both these compounds may or may not be optically active, depending upon the symmetry or asymmetry in a molecule. But generally, optical isomers have similar physical as well as chemical properties. In this video, we had a discussion regarding the isomerism and its types. In next video, we will discuss in detail regarding the conformation and conformational analysis. Thank you.